The following will help you with basic ideas of stoichiometry. The image in front of you is a flowchart that allows us to move from one unit to another and from one substance to another. So note, when you're going between grams and moles, we're always using molar mass. Particles and moles, we're using Avogadro's number. And when you need to go from one compound to another, one substance to another, we're going to utilize the mole ratio. So let's look at a couple basic examples to help us through this flowchart. Here's the first one. We're going to use the combustion of propane, which is the equation in the upper left for all of these. So here is my equation. It's propane plus 5 oxygens will produce 3 carbon dioxides and 4 waters. Okay, so here's my first problem. How many moles of O2 are needed to produce 1.75 moles of CO2? So how many moles of this do I need if I made that 1.75 moles of CO2? So I have moles of one compound, as you see on my flow chart, and I want to know moles of another. So moles of one to moles of another is simply a one-step problem. Okay? So the first thing we need to do is plug in our value. I have 1.75 moles of CO2, so I'm calling CO2 substance A. Okay, so automatically with T-charts, this unit's going to have to go on the bottom. Well, when I'm dealing with mole ratios, I'm going to use my coefficients. So there's a 3 in front of the CO2, so that means I need 3 moles of CO2. Then the other side is moles B. I'm going from moles A to moles B, so that's going to go on top. Whatever I'm coming from goes on the bottom. Whatever I'm going to goes on the top. So moles A are on the bottom, moles B is on the top. Well, what's moles B? Moles of oxygen. So it should be a 5 because mole ratio is using the coefficients. And there's my 5 moles of O2. If it's on the top, we multiply. If it's on the bottom, we divide. So 1.75 times 5 divided by 3 is 2.92 moles of oxygen. So that's a moles to moles problem utilizing the mole ratio, which uses the coefficients in my my equation. Let's look at another example. Here it says how many moles of water are produced from reacting 23 grams of propane, C3H8. So I have 23 grams of this, and I want to know how many moles of that I make. Okay, so here's the trick again. You're only dealing with 2 substances. I have grams of the first substance, and I want moles of the other. So if I take a look at that, I start here, and I want to go here. I'm starting at grams, and I'm going to moles. So that's 1, 2 steps. So if I plug in my grams of C3H8, I need to go to moles first, then I need to utilize the mole ratio. So going to moles, I need to utilize the molar mass. Well, simply put, the unit on the top of my previous step, when I go down to the next step, has to go there on the bottom. And how many grams is that? It's the molar mass. So if I add up 3 carbons and 8 H's, that's 44 grams. Well, 44 grams is 1 mole. So all of these relationships here is 1 mole. So I simply put 1 mole on the top. So now I'm sitting here. I want to go over to here. That's my goal. And sometimes it helps to underline that. I want moles of water. So I want moles of the other compound. So, as always, I bring the unit down to the bottom. So I'm going to have moles of C3H8. In this case, mole ratio utilizes my coefficients. Well, there's a 1 there. So it'll just be 1 mole of C3H8. Well, what am I going to? I'm going to moles of water. So it should be moles H2O, and because it's the mole ratio, I'm going to use the coefficient. So that should be 4. Now I multiply on the top, I divide on the bottom, and what I should get is 2.09 moles of water. So that's a 2-step problem. If you write your number in the first step, you have 2 more steps after that. Let's take a look at our final example. This one, I try to change it up a little bit just to make sure that you're understanding all the parts of my flowchart. It says how many particles of H2O. So that's the question. So I'm going to go to particles of my second compound will be produced if that many grams of CO2 is created. So I'm going from CO2 to H2O. Simply put, CO2 is the beginning, H2O is the second or the ending of my two compounds. So I have grams of CO2 and I want particles of H2O. Grams of my first substance, particles of my second. Well, if I plug in my first value, which is 89.5 grams of carbon, how many steps is that? 1, 2, 3. If it was grams of grams, which is the most common problem, it'd be 1, 2, 3. So 3 steps regardless. So what am I going to do? I'm going to take grams to the bottom. Always when I'm using mass in a T-chart, it's molar mass. So 1 carbon and 2 oxygens, 12 plus 16 plus 16 is 44. I equal that to 1 mole. So now I'm sitting here in this box. Now I need to get over here. Remember, the goal is here, particles of my second compound. So mole ratio utilizes my coefficients. So CO2 is going to go on the bottom. And what is the number, the coefficient in front of CO2? It's a 3. So there I am, 3 moles of CO2. Now I've left that box and I'm going towards moles of the second compound. What's the moles of the second compound? My H2O. So it should be 4. That's my ratio. There I am. Now moles will go on the bottom, which is always 1. Only the mole ratio can use something other than 1. So those come from my coefficients. Now, if I were going to grams, I would use the molar mass, and the molar mass of water is 1 plus 1 plus 16, which is 18. But I'm going to particles. So we use Avogadro's number, which is always the same. It's 6.022 times 10 to the 23rd particles of H2O. So now I multiply the top and divide the bottom. And my answer is 1.63 times 10 to the 24th particles of water. So we can have 1-step, 2-step, or 3-step problems. But if you just envision moles in the middle, grams and particles on each side, if I want to go from one compound to another, I need the mole ratio. And that mole ratio is simply my coefficients in the balanced equation.